Okay, so we are picking up where we left off yesterday. We're working with 4.1, equivalent fractions. So we had just gone through a lot of these definitions that we have, some notes that we have for going through and working with these things. Again, the big thing I want to emphasize, whether it be in this class or your future classes, big one, always reduce your fractions down if you possibly can. There are going to be very, very, very few instances where we want to leave our answer not fully reduced. And that generally comes in the form of the problem will tell you about that, hey, don't fully reduce your final answer because we have our own reasons for it. But if it doesn't say that in the problem anywhere, always fully reduce your fractions down. This is going to be especially true when we have test 2 next Friday, which is going to have fractions on it. You will want to fully reduce all of your fractions down. If you do not do that, you are not going to get full points. Okay? So you worked with our definitions that we had here, multiplying things on top, dividing top and bottom, multiplying top and bottom, dividing top and bottom. We have the cancellation rule, which is basically just the fancy way of saying I have something fully reduced in our definition for it and how we cancel things out. And we left off right before going through a couple examples that we have here. So we're going to go through both of these in detail. We already have the answers given to us, so we can at least check our work, assuming I've put the right numbers in this time also. But we can go through this and see what we're getting with each of these and then go on from there. So I'm going to jump us over to our whiteboard, but these are the two examples that I'm going to be referencing for fully reducing down fractions. So we'll jump over to our whiteboard here. Come on. There it goes. Mouse is not designed to cooperate with me today. All right, so our two examples that we have. Our first one, we are starting with 42x to the third y over 14x to the seventh y squared. Okay, and again, we are told to fully reduce these fractions down. Now, when you're going through these, and we have just a fraction like we have written out here, everything is multiplying and dividing together, so fantastic. It makes life even easier. My recommendation when you're doing this, if we have numbers and variables showing up, only work with one at a time. I'm only going to work with the numbers, then I'm only going to work with the x's, then I'm only going to work with the y's to figure out how to cancel these things. Now, I'll go through and show a couple methods with this on how you could go about canceling these things out. I'm indifferent as to which one you would like to use. They will all work, but you do want to choose one of them and move forward with that. So our first one we're going to take a look at, okay, I want to fully reduce, I want to cancel out and work just with my numbers. So all I'm going to do first is be looking at 42 divided by 14. We're saying, does 14 evenly divide into 42? So we can check with the calculator, 42 divided by 14. I'm just doing this off screen, but you can do that as well. So I get, just for the numbers, 42 divided by 14 is going to give me a positive 3. That's going to go in the numerator spot. So I'm going to just, in my first line of work, that's all I'm working with. And again, I'm going to show extra steps with this. As you guys get more comfortable with it, you'll get faster and not have to show all of these steps in here if necessary. So I have my numbers simplified. Now I'm going to work with the x's. So one of the other things that I think people do not credit doing, and I think it's extraordinarily helpful when we do this, is writing things out in expanded form to see what does and does not cancel. I also wrote an extra x in there. It should be a y. So what I'm going to do, again, I'm showing you this method. You do not need to use this for every problem, but I'm going to expand the exponents and the variables that I have associated with x. So x cubed is the same as saying x times x times x, leaving y at the very end up top. x to the 7th, the same as saying x this many times. 2, 3, 4, 5, 6, 7. So again, I'm only working with the x's right now. We'll deal with the y's later. I'm going to leave those as they are. And now we're going to cancel things out best we can. I have 3 x's up top. I have 7 x's down below. Anything divided by itself is going to cancel out. So 3 of the x's on top and 3 of the x's on the bottom are going to cancel out. And that puts us with 3y over x to the 4th y squared. Okay. So again, all I did, should have a square in the numerator spot. There we go. All I did was cancel out the x's. It was my only thing I did in that line, couple lines of work. And we can do the same thing with our y's if we want to do that. I have 1 y on top. I have 2 y's down below, so a single 1 is going to cancel out for both. And then what's left over? 3 over x to the 4th y. I cannot reduce anything else. No numbers cancel each other out. No variables cancel each other out. And I am done. And it would appear, based on what I have written in as the answer for this thing, it's written in incorrectly. So we should be getting 3x to the 4th y. The notes are a little bit off on that. Okay, we'll take a look at we'll take a look at one of the other ways we can go through in solving these things. Actually, I'll just show you guys how you can work this out if you'd like to. So you can go through and write everything out in expanded form. You're welcome to do that. Oops. So alternatively, I'm just going to rewrite our original problem that we have. X to the 3rd. If you're going through this problem and you say, okay, well, I'm just going to work with these, I don't want to write everything out in expanded form, that's fine. And for the record, our expanded form is what we have right here in this line, where we've expanded out x cubed and x to the 7th into everything multiplying out. That's fine as well. So let's say I don't really want to do that. I just want to work with each of these things individually and not expand them out. Okay, that's fine. Then if you just end up going with a couple lines of work saying, okay, well, I'm just going to have, again, working just with the numbers, 42 divided by 14 is going to give me 3. And you can do some of this mental math, a fair amount of this math in your head. You're saying, I have 3 x's on top, 4 x's down, 7 x's down below. 3 of each of those are going to cancel. So I'm going to have y to the 4th left over, or x to the 4th left over, I should say. Good Lord, it's pretty obvious that I really want the weekend to be here, so I don't keep making these mistakes. Just say I'm just working with the numbers like for x, cancel those out. I have a y on top, I have 2 y's down below, so 1 is going to cancel from each. We're getting y, and we get our final answer there as well. So if you're able to do a fair amount of that mental math that we did in our first example, then go for it. If that's going to save you time, I have no issue with that. Now, a couple people, when I've done this lesson in the past, a couple people ask, okay, well, can't I just use my calculator to plug this in? I believe I've shown you guys, and if not, I'll show you here when we get to, after done with our next example, ways that we can use a graphing calculator to go through and simplify a lot of these fractions for us. And what's really nice about being able to do that is it will fully reduce a fraction down if we are working only with numbers. The TI-83 and the TI-84 graphing calculators will not reduce any variables that you plug into it. And I know some of these calculators have the ability to let you type in actual variables and letters, which is cool. It will not fully reduce and cancel out fractions and variables. Will not fully reduce and cancel out variables. It will only work with numbers. So if you guys do have a graphing calculator, we are going to be working with that, and I'll show you guys some, or just give you a reminder on how we can work with that, because I can't remember if it's this class I've done this with or I did it my office hour. But regardless, I am going to show you guys a calculator trick to do some of this reducing down after we go through this second example. Okay, so our second example that we have here, we have 50ab to the fourth, and then 125ab to the third. And yep, everything's written down correctly. Okay, so yeah, we're told to fully reduce this thing down. So again, my recommendation, only look at one thing at a time. Only look at the numbers, only look at the A's, only look at the B's. Pick one and do this thing in parts. So I'm just looking at the numbers, saying 50 and 125. Well, 125 cannot evenly go into 50. So I need to determine what is the greatest common factor between 50 and 125. Meaning, what is the largest number that evenly divides into both of those? And the number that we're going to be using for that is 25. 25 goes into 50 2 times, and 25 goes into 125 5 times. So the numbers are going to reduce down. And again, I'm dividing the top and bottom by that 25 essentially. So I'll write that off to the side here. Now I've done nothing to the number, the variables, I should say. So those are going to come down exactly as they were. So first we looked at our numbers. Now we're going to look at our A's, so our first variable. The numbers are done. So they're just going to come down exactly as they are. I have an A on top. I have an A down below. I just have one of each of them, so these things are going to cancel out, which is nice. And now I'm just left with b to the fourth over b cubed. I have 4 b's on top. I have 3 b's down below, which means I'm going to have 1 left over because I can cancel 3 of those things out in the top and the bottom. So I'm going to have 2b on top. And then, whoops, I wrote this thing out wrong. Should only have a 5 down below there. Divided by 5. And I can't simplify any of the numbers down any further. 2 and 5 don't go into one another. I have a b left over, but that can't cancel with anything else, so I get to that answer there. Okay. Now I am going to show you guys how we can go through and work with a graphing calculator to do some of this fraction work for us. Now, I do not want you guys to become reliant on using the calculator to do a lot of these fractions, reducing fractions down for us. It's very useful as a tool to make that happen, but do not be reliant on it. I think the big thing that kills people with fractions is they get comfortable with and only know how to work with a fraction on a calculator. You don't want to be in that boat, especially for the test. So I'm going to jump us over to the graphing calculator. I'll show you guys a trick on how we can go through and reduce those things, or reduce fractions down with that calculator. So we'll jump over to that. Okay. So again, I'm going to reference our first 2 examples that we had, that we just worked with, but how do we go through and simplify those things on a calculator? So if you have a graphing calculator, now is the time to get that out. I'll give you guys a minute here, like 30 seconds to get that out if need be. It's saying on here that we are working with a TI-84 plus. Well, the nice part about the TI-84 and TI-83, the button commands are the exact same. All it's going to be different is the way that it's displayed on your calculator. But otherwise it'll do the exact same operations, exact same process with all of that. Okay. So one of the big things that I am going to emphasize as we are putting these things in, whenever you are working with a graphing calculator, parentheses are your best friend. So make sure you are utilizing those. So what we're going to be typing in here, I'm trying to get the spotlight to work. It's kind of glitching on me a little bit. There we go. So what we're going to do is we're going to work just with the numbers 42 divided by 14. So what we're going to do is I'm going to say, all right, for my numerator, put in parentheses, put in everything I'm working with my numerator, which is 42, end the parentheses. Then I'm going with divided, parentheses, 14, and end the parentheses. So from here, we need to check this and make sure, okay, everything that I have written in as a number is the exact same as what I have been given on my paper. So fantastic, we have that. Now before we hit enter, this is where final step of having this give us a fraction answer is very, very handy. On the left-hand side of your calculator, third row down, we're going to click on the math button. You should see this come up. And of course, it's spotlight's going away. So I'm going second, or just going right into math. The first option, frac. You can either hit the number 1 to select that or hit enter. I'm going to use enter for this. Should see 42 divided by 14 frac. That tells the calculator, give me an answer as a fraction. So then I hit enter one last time. We're getting 3, which is what we got before. Now we're expecting, okay, well, we should be getting a fraction answer. Remember, any whole number that's just written as a whole number is implied to be divided by 1. We don't write it in because if there's so many invisible ones surrounding a number or a variable, it would just become an absolute mess to have typed in or written down on a piece of paper. So again, that's using the parentheses. I'm trying to get this spotlight thing to work. It doesn't want to work when I have this up. So we're using the parentheses, typing in our numerator, divided by, in parentheses, our denominator. Then we're going to math frac. That gets us our answer. So working with our second example that we had 50 divided by 125. So I'm going to do the same thing that we're doing here. Parentheses, 50, and that parenthesis, divided by, again in parentheses, 125, and then end that parenthesis there. I'm going over to math on the left-hand side, clicking on that. First option, frac. I'm going to hit 1 this time just to see that it works with that also. 50 divided by 125, my answer is a fraction, and we hit enter, and bam, 2/5. Same thing that we got before. So I would highly recommend, and I'm all on board with you guys using the graphing calculators and this tool to help you guys check your answers if you're working with fractions. Nothing wrong with that. But do not be dependent on your calculator to do this all the time. Do not forego learning how to do this by yourself just because the calculator does it a bit quicker. Okay? The last thing you want is to be dependent on that piece of technology and heaven forbid its batteries run out on a test and suddenly you're not sure what to do. Okay, so I'm going to minimize this thing. We're going to go back to our notes. Okay, and this is everything that we had for the 4.1 materials, working with equivalent fractions, scaling these things up or down, Again, the principle with scan them up is the exact same as what we did with reducing them down, except multiplying instead of dividing. And speaking of multiplying, that is what our entire 4.2 section is about. So okay, I'm going to go through a couple, our definition, how we write this thing out symbolically, and then we'll go through our examples that we have listed and some different options that we have on how we can skip some steps and use some shortcuts as well, because shortcuts are nice. So when we are multiplying fractions, we have our multiplication rule, and this dictates everything that we can or can't do with this. So to find the product of the fractions a over b and c over d, multiply the numerators and denominators together. So symbolically, what this looks like is I have a over b times c over d, and all I'm going to do when I am multiplying fractions is multiply straight across. A times c, just like we get here, and b times d, just like we get here. So this is unique specifically to multiplication only. We only multiply straight across as we are going through and simplifying these things. I want to make a note of it again, because this can and this will show up. All whole numbers can be rewritten as fractions. All of them have a denominator of 1. So a couple examples here. Number 5. It's implied that 5 is a fraction, 5 over 1. 14 is implied to be 14 over 1. Negative 218 or 280 is expected to be negative 280 divided by 1, and so on. Okay. So a couple of the notes I want to make for you guys. Always make sure that you align the fractions so you know what numbers or variables are multiplying where. A lot of people will just very haphazardly write some fractions down, and I'll show you guys an example of what that looks like here with some of these ones in a second. But make sure your work is neat and organized. If you are multiplying fractions and you accidentally multiply the wrong things together, you're going to get wrong answers. So make sure the numerators align with one another, make sure the denominators align with one another, and then multiply straight across. And the same thing continues as we did with 4.1. Always fully reduce your final answer fraction. A lot of people lose points in the test because okay, well, I multiplied these things together and I'm done. It's like, no, we absolutely need to have all of this fully reduced down. Okay. And so we have, and it's kind of already written out here for us, so we'll just follow along with what we have written out here. So if we are multiplying the following fractions together, so let's say we have 3/4 times 16/15. Well, okay, if we're multiplying them together, so checking our notes that we have back up here, how do we write this out symbolically? Well, we're starting with 2 fractions multiplying, and then we combine it into one fraction where we have the numerators multiplying together and the denominators multiplying together. So that's all we did from our first to our second line of work. Fantastic. Now we actually multiply those things together. So 3 times 16 gives us 48. 4 times 15 gives us 60. And then from here, 48 divided by 60, we reduce that down either by finding the greatest common factor or plugging that into our calculator, and we get 4/5 for our final answer. Looking at our second example, we have 18/5 times 25/3. And again, we're following the exact same process. I have 2 fractions multiplying. Let's put it together as a single fraction. Numerators multiplying together, denominators multiplying together, and then apply your calculator and actually multiply them together. Because for me, I don't know what 18 times 25 is off the top of my head, and I don't expect you guys to know that either. If you do know that, great, but you can apply the calculator to multiply those if need be. So that gives us 450. 5 times 3, that's going to give us 15. And we're saying, okay, can 450 over 15 be reduced down? And it can. And we get 30 for our final answer, which is really handy. So I am going to show you guys, again, I want to just emphasize this, of how we can work with and multiply these things together on the calculator. So I'm going to jump us back over to our graphing calculator. So if you still have that nearby, grab that again. So we're going to be using that. So our two fractions that we are working with, we're going to look at our first example, that 3/4 times 16/15. Now, because we have some nicer numbers, we don't have additional variables showing up in here, we're going to slightly adjust how we write this thing out in the calculator for this. So instead of putting the numerator and denominator in parentheses, we're just going to put an entire fraction inside of parentheses. So I'm starting with parenthesis, 3 divided by 4, end of the parenthesis. So that whole fraction is encased inside those parentheses. The main reason why I'm emphasizing that you do that is because sometimes a lot of people will just say, all right, well, I'm just going to write as 3 divided by 4 times 16 divided by 15. The calculator does not know what is and is not multiplying and dividing and what should be multiplied and divided together. So we need to make it abundantly clear to the stupid piece of technology what we want it to do. So I'm saying the fraction 3/4 times, start another parentheses, the fraction 16 divided by 15, end of the parenthesis. And this makes it extraordinarily clear to the calculator that I have a fraction multiplied by another fraction. If we do not do this, I've seen a lot of points get missed on the test because we just do 3 divided by 4 times 16 divided by 15. And really weird things can happen with a calculator if you do that. It is programmed to follow PEMDAS just as we do, but it might mix up the orders, and I've seen it do that sometimes based on how people type those in. So again, use parentheses. First fraction in parentheses times the second fraction in parentheses. And before we hit enter, let's go over to the left-hand side and hit math, and then our frac option. So I want 3/4 times 16/15, and I want that answer as a fraction. Hit enter again, 4/5, which is really nice. So looking at our second example that we have 18/5 times 25/3. So again, enter each of those fractions inside a set of parentheses. So I'm doing parenthesis 18 divided by 5, end the parenthesis. There's my first fraction. Times, new set of parentheses, 25 divided by 3, end that parenthesis. So I have my first fraction times my second fraction. Going over to math, option 1, frac, and hit enter. We're getting 30. So you absolutely have this tool at your disposal when you're going through and solving these equations, or not equations, these simplifying these fractions down. And again, I recommend that you use this to save you some time, but do not become dependent on it to solve all of these problems. It does not end well for people if they're dependent on that. Okay. Now the other method that I want to show you guys will jump us back over to our whiteboard because we're going to use the exact same. Actually, we'll go to our notes first. Just want to show it there. So the other option that we have at our disposal, and we can use this, very helpful when we're going through and writing these things out by hand. We have what's called cross-canceling. So multiply and cancel, or cancel and multiply. It's kind of interchangeable, but this helps, I think, with the reducing process. So we can also cross-cancel fractions before multiplying them, and this helps reduce steps after we multiply things together. Essentially, we are doing the cancellation process that we would be doing in our first two examples and our last step at the very beginning of the problem. This also works with variables using the exact same method. So the examples here only are given with numbers. It will absolutely work with variables as well. So I'm going to jump on over to our whiteboard and we'll go through these exact same problems, just showing how we can use this cross-canceling method. I'm actually going to close the emulator here because I think that's slowing down the computer quite a bit. There we go. Okay, jumping us over to our whiteboard. Oops, not what I wanted. Just moving this thing. It's not liking that I'm doing that, but whatever. We'll just divide these things out all the same. So our first example that we had 3/4 times 16 over 15. Now, again, our process that we went through originally was to multiply straight across and then reduce down. We are going to use cross canceling to do some reductions before we do anything else in this process. So I'm saying, and this is where it gets its name of the cross canceling. So I'm looking across the multiplication sign to anything that's in the numerator and the denominator spot. So I'm going to work with 3 and 15 first. Do these two numbers have any greatest common factor with them that isn't 1? And we know that 3 evenly multiplies into both of these numbers. So 3 goes into 3 how many times? Once. 3 goes into 15 5 times. So I can reduce each of those parts down. I'm looking and doing the exact same thing now with 4 and 16. I'm saying, what is the greatest common factor between 4 and 16? Well, 4. 4 goes into 4 once. 4 goes into 16 4 times. We have our new fractions right there. My recommendation, because there's a lot of cancellation that was going on there, rewrite your fractions. So I have 1 over 1 times 4 over 5. And now I multiply straight across. 1 times 4, give me 4. 1 times 5 is going to give me 5. I get 4/5, the final answer, which is nice. I'm going to take a look at our second example that we had with that. So we have 18 over 5 times 25 over 3. So again, I'm using cross cancellation here. I'm looking to see, can I reduce anything going across the, the multiplication sign? So I'm looking at 18 and 3. And do they have a greatest common factor between them? And they do. 3 goes into both of those numbers. So 3 goes into 3 once. 3 goes into 18 6 times. Do we get that there? And now I'm looking at 5 and 25. This is where it gets its name of the cross cancellation. Greatest common factor between 5 and 25 is also going to be 5. So 5 goes into 5 once. 5 goes into 25 5 times. So I've now canceled some things. Let's rewrite this all as some new fractions. So I have 6 over 1 times 5 over 1. And I could rewrite that one step further if we want to. Remember, anything that's over 1 is just going to be that numerator value. So 6 times 5 is going to give me 30, which is our final answer that we got with our other methods. Okay. Now I do have it written in the notes that if you want to detail this process out for yourself by expanding and finding the prime factorization of these things, you are welcome to. There's 2 examples using this same pair of fractions that we have that you are welcome to use. I think it's a bit more, it takes a little longer than I would like it to, but is another option that is at your disposal that you're welcome to use. I'm not going to detail that one out as the examples. Again, I think it takes a bit too long, in my opinion, but you are welcome to go ahead and take a look at those and utilize that method if you would like to. And again, we have all of these different methods to go through and reduce fractions down when we are multiplying them together. I do not care which one you guys would like to use on the homework or on the test. I just need to see that work is shown and detailed out using whatever method you choose for that partial credit. Okay. So this is everything that we have for multiplying fractions together. Right, I'm going to end the recording there because that's everything that we have for today.